Hello everybody, welcome to my channel Reshma Physics. So in last two classes, we completed the two applications of Gauss law. One is the electric field intensity due to conducting sheet and other is the electric field intensity due to infinite line charge. Now in this video, let us discuss about electric field intensity due to charged sphere. Right? Now spheres will be hollow sphere and solid sphere. So here we are talking about solid sphere. Right? We are talking about solid sphere. Okay. So now here three cases we will discuss. One is when point lies outside the sphere, when point lies outside the sphere, when point lies inside the sphere, and when point lies on the sphere. Right? So now, first, let us discuss about when point lies outside the sphere. For this, let us consider a solid sphere, right? The charge Q is uniformly distributed on this sphere. A charge Q is uniformly distributed on this sphere. Let O be the center of a sphere, R be the radius of a sphere. Right? R be the radius of a sphere. Now, first, let us consider a point P outside the sphere. We are considering the point which is lying outside the sphere. The point P outside the sphere. Okay. Now, this point is at a distance R from the center of a sphere. This point P is at a distance R from center of a sphere. Now, first let us talk about electric field direction. Here we said that charge is distributed uniformly throughout the sphere. Charge is distributed uniformly throughout the sphere. When charge is distributed uniformly, so according to the principle of symmetry, the electric field, the magnitude of electric field will be same or constant at each and every point on the sphere. And such electric field direction will be radially outwards from the sphere. So as charge is distributed uniformly, according to the symmetric rules, okay, the law of symmetry, the magnitude of electric field will be same at each and every point of the sphere, and such will be directed radially outwards, the electric field direction. Now next, we have to find electric field intensity at this point at this point P. To find the electric field intensity, we have to assume a Gaussian surface, okay, passing through this point P. Now, let us imagine a Gaussian surface passing through this point P. Now, this is Gaussian surface. A Gaussian surface passing through this point P. Right? Now, this small r becomes the radius of Gaussian surface. Right? O as usual the center. R becomes the radius of Gaussian surface. Now next, let us consider a small area around this point P. And this area is denoted by vector ds. And the direction of these vector ds will be along the outward normal drawn from this elemental area. Now, we considered a small area around the point P on Gaussian surface. Now, the direction of electric field is radially outwards, and the direction of vector ds will be along outward normal drawn to the surface. Now, first, let us write the total flux passing through this Gaussian surface. So, now the total flux passing through Gaussian surface, right? Through Gaussian surface. So, what is the flux? Pi is equal to integral E dot ds. Now, here we said that as a charge is distributed uniformly, the electric field magnitude is same at each and every point on the sphere, we said. So, the constants, here E becomes constant. So, I am writing E outside of integration symbol, because constants we will not do integration for constant. As it is, we will write. So, now integration is only for ds. Now, what is ds? Here, ds, integral ds, is the surface area of Gaussian surface, right? Now, small r is the radius of Gaussian surface. So, surface area becomes 4 pi r square. Surface area becomes 4 pi r square, right? So, now substituting this value, now here in pi, we get E 4 pi r square. Here we substituted E integral ds. In place of integral ds, we substituted 4 pi r square. Right? Now next, according to Gauss law, what the Gauss law is saying? The flux through any closed surface is equal to the 1 by epsilon naught times the total charge enclosed within the closed surface, which is placed in electric field. Right? So now substitute here. So E 4 pi r square will be equal to Q by epsilon naught. So now electric field intensity at a point P, at the outside point P, due to charged sphere, uniformly charged sphere is, now we are bringing this to this side, 1 by 4 pi epsilon naught Q by r square. Alright? This is when point lies outside the sphere. If you want to write the notes, pause my video and just copy down the notes. And for theory, when I am explaining, write down the running notes. Right? Now the next one. When point lies on the sphere, case 2, when point lies on the sphere. So now this is the sphere. As usual, center O, radius is R. Right? Radius is R. Now point is on the sphere. So Gaussian surface will also be taken on the sphere only. Gaussian surface also will be taken on the sphere only. And the distance of this point P from center O is R. So now here, by seeing the diagram, we are understanding R is equal to capital R. So the intensity becomes the same formula, but instead of small r, we are placing capital R. Right? In first case, by seeing the diagram, what we are understanding? R is greater than R. So these are the two cases. Now, let us move for third case. The third case is when point lies inside the sphere. Now, if it is hollow sphere, no issue. In case of hollow spheres, easily we can say, in case of hollow spheres, what happens? The total charge will be resides on surface of the sphere. And inside the sphere, there will be no charge. When there is no charge, there is no electric field. So electric field intensity will be zero in case of hollow spheres. But here we took solid sphere, right? But here we took solid sphere. So for solid spheres, inside the sphere also charge will be present. Okay, charge will be present inside the sphere also. So now I am taking a solid sphere. As usual, Q charge is distributed uniformly throughout the sphere. Inside the sphere also charge is there. Now as usual, O is the center, R is the radius of the sphere. Now inside somewhere here, I took point P. Now this point P is at a distance some R dash from the center of the sphere. Now as usual, let rho be the charge density of a sphere. And charge density means charge per unit volume, right? Charge per unit volume. Okay, so now in order to find electric field intensity at a point inside the sphere, as usual, what we have to do? We have to assume a Gaussian sphere passing through this point P. Next, what we will do? We will assume a small area around this point P. What is the direction of electric field? Radially outwards. What is the direction of it? Vector ds along outward normal drawn. Right? This area is denoted by vector ds and the direction is along the outward normal drawn. Right? Now first, let us write the total flux through Gaussian surface. Total flux through Gaussian surface. So pi is equal to integral E dot ds. Right? Now this, as usual, how we will write? E ds cos theta. Now here angle ds and E both are in same direction, parallel to each other. So angle will be 0 degrees. And the value of cos 0, 1. The value of cos 0, 1. Alright. So now, as for principles of symmetry, as charge is uniformly distributed throughout the entire sphere, what we will say? The magnitude of electric field will be same at each and every point on the sphere. So how we will write? Pi is equal to E integral ds. E is same or constant, will not change. So now, what is integral ds? Surface area of Gaussian surface. Now what is that surface area? Sphere, no? 4 pi r dash square, because I assumed as r dash from 0 to p, the distance is r dash. Now substitute. Pi is equal to integral, in place of integral ds, 4 pi r dash square. Next, what we will do? Gauss law. What is Gauss law? The total electric flux through a closed surface is 1 by epsilon naught times the total charge enclosed within the surface. Now substitute here in place of pi. What you will get? E 4 pi r dash square is equal to q dash. Let the charge on Gaussian surface be q dash. Okay. So q dash by epsilon naught. Right? Q dash by epsilon naught. Right? Now next, E 4 pi r dash square equal to, now how can I write q dash? Now here, we define the charge density as charge by volume, no? So charge will be equal to volume into charge density. Can I write? From this formula, charge is equal to volume of Gaussian surface into charge density by epsilon naught. Right? Now next, E 4 pi r dash square is equal to volume of Gaussian surface. R dash is the radius we are saying. So volume will be 4 by 3 pi r dash cube into rho by epsilon naught. Rho is the charge density. Now, what will be the rho? Right? Separately here I am writing rho. Nothing but charge by volume we said. Right? The charge of sphere. The charge of sphere by volume. Right? Why I wrote sphere? Why I wrote sphere? So, charge of sphere by volume. Charge of sphere, Q. Volume, 4 by 3 pi, capital R cube. Because for sphere, the radius is capital R, we are saying. Right? For sphere, the radius is capital R. Then why we wrote sphere? Why means this Gaussian surface is within this sphere only. Right? The point we took inside the sphere. So Gaussian surface is within the sphere, means of this whole charge density. The Gaussian sphere is within this whole charge density rho. So only we are writing charge of sphere by volume. Now let us substitute here. E 4 pi r dash square equal to 4 by 3 pi r dash cube into what is rho? This 3 if it comes up, 3q by 4 pi r cube. So 3q by 4 pi r cube by epsilon naught. 4, 4, 3, 3. Pi strikes off. Now what is remaining? E 4 pi r dash square equal to here r dash cube into here q is remained, here epsilon naught and r cube is remained. Correct? And now here see r dash square, r dash cube. One r dash will be remaining. So E into 4 pi r dash q by epsilon naught r cube, or E equal to 1 by 4 pi epsilon naught q r dash by r cube. So this is electric field intensity inside the, when point lies inside the sphere. So up to here, we are considering the total flux through Gaussian sphere. And we got it as pi equal to E 4 pi r dash square, because r dash we are taking distance from O to P. Now next we followed the Gauss law and we substituted the q dash by epsilon naught, because Gaussian surface. Gauss law for Gaussian surface. Q dash is the charge we are assuming. So q dash by epsilon naught. The total charge is q for sphere and the charge in Gaussian surface is q dash. Alright. Now next, this q dash can be written by following this formula as charge density into volume of Gaussian surface. Volume of Gaussian surface is r dash is the radius we said. So 4 by 3 pi r dash into rho by epsilon naught. Now here in place of rho we are substituting for charge, because here Gaussian surface is inside that sphere with a charge density of rho. So only charge of sphere by volume. Right? So we got 3q by 4 pi r cube. On substituting, we get E equal to 1 by 4 pi epsilon naught q r dash by r cube. Okay. So this is about when point lies inside the sphere. Right? Hope you all understood. So thank you for watching my channel. Stay with my channel. to receive more videos on graduation physics. Thank you.